Do you need to learn more about how to sketch a plane curve and convert a parametric equation to a rectangular equation by eliminating a parameter? I'll show you some simple steps that you can follow to do both of these and walk through some example problems. Welcome to Understand the Math. We've created free guided notes that you can use as you watch this video and placed a link to them in the video description below. There's space in the notes for you to highlight the important concepts and to fill out the answers to the examples that we're going to do. Let's start by seeing what a plane curve looks like and learning about the equations that we can use to describe it. This is an example of a plane curve. This plane curve can't be described in terms of rectangular or polar coordinates. Some plane curves can, and some can't. Plane curves like this can be thought of as the path of a point moving in the xy plane. The coordinates of the point are given by x of t and y of t. A plane curve is the set of all points f of t, g of t, where x is equal to f of t and y is equal to g of t. These equations are called parametric equations. We'll now walk through three example problems where we're given parametric equations, x is equal to f of t and y is equal to g of t, and asked to sketch the curve. I've listed three steps that we can follow. The first step is to create a table with values of t, x, and y. The second step is to plot the points, starting with the smallest value of t. And the last step is to use an arrow to indicate the direction of the curve. In the first example that we'll look at, x is equal to t squared and y is equal to t plus 2. And we're given that t ranges from -2 to 2. We'll first create a table of values. I've already filled in t since we were given that t ranges from -2 to 2. When t is -2, x is equal to t squared, which is 4, and y is equal to t plus 2, which is equal to 0. Following this same procedure, we get the following values for x and y. Let's now plot the values of x and y on our graph, starting with the smallest value of t. When t is -2, x is 4, and y is 0, so we have this point. Our next point is 1, 1, and then we have the point 0, 2, then the point 1, 3, and lastly the point 4, 4. We'll now connect these points and indicate the direction of the curve. In our second example, x is the square root of 9 minus t squared and y is equal to t. Since no values for t are given, we need to determine what values should be used. We know that 9 minus t squared must be greater than or equal to 0 because it's inside the square root. This gives us 9 minus t squared is greater than or equal to 0. So we have 9 is greater than or equal to t squared. This gives us plus or minus 3 is greater than or equal to t, which we can write more compactly as -3 is less than or equal to t is less than or equal to 3. Let's put these values of t into our table. We start with -3, then we have -2, -1, 0, and then we have 1, 2, and 3. Looking back up at these two equations, when t is -3, x is 0, and y is -3, the rest of our values look like this. Let's make a note that root 5 is approximately 2.2 and root 8 is approximately 2.8. We'll now put these values on our graph. When t is minus 3, x is equal to 0, and y is minus 3. When t is minus 2, we have x, which is about 2.2, and y is minus 2. The rest of our points look like this. We'll now connect these points and indicate the direction of our curve. So we now know how to handle an example when we're not given a value for t. If you're finding this video helpful, please give it a thumbs up and consider subscribing to my channel. Our third problem is a classic one where x is equal to 2 sine t and y is equal to 2 cosine t, and we're told that t ranges from 0 to 2 pi. To save time, I've included the values for t, x, and y in our table. These are computed just like we did in our first two examples. Let's now add these values to our graph. When t is equal to 0, x is 0, and y is equal to 2. This point is located here. Our next point is the point root 2, and I've already made a note that root 2 is approximately 1.4. This gives us x is 1.4 and y is 1.4, which places our point here. For our next point, x is 2 and y is equal to 0. The rest of our points look like this. We'll now connect our points, and hopefully it'll look like a circle. There we go, it does. And then lastly, let's put the direction of our curve. We started with this point and went to the right, so the direction of our curve is clockwise. This plane curve is a circle, and a circle can also be written in terms of rectangular coordinates. This brings us to our next topic called eliminating the parameter. As we just saw, some curves described by parametric equations can also be described by an equation in rectangular coordinates. Eliminating the parameter is the process of converting a parametric equation to a rectangular equation. I've listed two steps that we can follow to eliminate the parameter t. The first step is to solve for t in one equation and substitute it into the other equation, or use a trigonometric identity to relate x of t and y of t. The second step is to simplify the equation. Let's now walk through 3 example problems. In our first example, x is equal to t squared and y is equal to t plus 2. We'll first solve for t in our equation for y, and then we'll substitute it into our equation for x. We get t is equal to y minus 2, and that gives us x is equal to the quantity y minus 2 squared. This equation can't be simplified any further, and you might recognize this as an equation describing a parabola that opens to the right. In our second equation, x is equal to the square root of 9 minus t squared, and y is equal to t. Since y is already equal to t, we'll substitute this directly into our equation for x. X then becomes the square root of 9 minus y squared. This equation can be written more simply if we square both sides. This gives us x squared is equal to 9 minus y squared. We'll then move the y squared over to the left, and we'll get x squared plus y squared is equal to 9. This is the equation for a circle of radius 3. Our last example, which is a bit more challenging algebraically, is x is equal to 2 sine t and y is equal to 2 cosine t. This is the same set of equations that we graphed in example 3 when we were sketching plane curves. Since x is equal to 2 sine t and y is equal to 2 cosine t, we can't easily solve for t. Because of this, we need to use a trig identity that relates x and y. See if you can think of an identity that would relate x and y. You may have come up with sine squared t plus cosine squared t is equal to 1. We need to plug x and y into this equation, so we first need to solve for sine t and cosine t. In the equation for x, we see that sine t is equal to x over 2, and in the equation for y, we see that cosine t is equal to y over 2. Our identity equation then becomes sine squared, which is x divided by 2 squared, plus cosine squared, which is y divided by 2 squared, is equal to 1. This gives us x squared over 4 plus y squared over 4 is equal to 1. And if we multiply both sides of the equation by 4, we end up with x squared plus y squared is equal to 4. This is the equation for a circle of radius 2. I hope that you now feel more comfortable sketching plane curves and eliminating the parameter and can have the confidence to do some problems on your own. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.